Third question, which is a change of pace, we've got combustion, and it states a sample of a compound that contains only the elements carbon, hydrogen, and nitrogen is completely burned in an oxygen molecule to produce 44 grams of carbon dioxide, 45 grams of water, and some nitrogen oxide. A possible empirical formula for the compound is one of these four. Now, to answer this question, we're going to look at this again. So we're going to disregard oxygen and we're going to disregard nitrogen both because they do not have any relation here. What we can look at though, and what is beneficial to us, is the carbon and the hydrogen. Now, he's asked for carbon and hydrogen, like in the question, because you see there's no like nitrogen, or nitrogen isn't really significant. But carbon and hydrogen in relation to carbon dioxide and H2O, there's a ratio. We're going to cover that later though. As for now, we're going to take it very simple. So in the equation, you've got 44 grams of carbon dioxide. And so we can take the carbon from the carbon dioxide here. And we're going to, like carbon dioxide itself, it has 44 grams, right? And so mass over molar mass gives you 1, and then you multiply by 1 because the ratio of C to C, carbon to the carbon inside the carbon dioxide, that's 1 to 1. And so you have to multiply by 1 just to make sure that the ratio doesn't change it. It turns out also to be 1. And so like now we have C and D, they're cancelled from the answers. We keep going to do hydrogen, moles of hydrogen. We have 2.5 moles of hydrogen because we have 45 grams of hydrogen dioxide, right? And hydrogen dioxide, we know it's 18. 18 divided 45 over 18 gives you 2.5. And now here is where this differs from the carbon. Do you see how there's hydrogen, like, oh no, not hydrogen dioxide. I said that earlier, but it's not hydrogen dioxide. It's H2O right here. And the relation from H to H2, there's 2 to 1. And so you're going to need to make sure that you multiply by 2 here. You're going to need to, it's going to be 2.5 originally, 45 over 18, and then because mass and molar mass. And after that, you're going to multiply by 2 because of the ratio. And it becomes 5. And as we look at the questions, B has CH5. And the reason why, once again, we didn't look at N was because it isn't relevant to the question. Like, there's no need for it. It's combustion. It focuses on carbon and hydrogen. And as for the fourth question, and I believe this is a shout out to the people who had thrown some very good feedback in the comments of the previous videos, I'm going to leave this question to you. However, I do entrust you with the responsibility of not cheating. And so if you're gonna leave the answers to what you believe this question could be in the comments, that would be greatly appreciated. A compound consists only of carbon and hydrogen. 13.725 grams of carbon dioxide and 6.742 grams of hydrogen of H2O are formed during complete combustion of the compound. What is the empirical formula of the unknown compound? And to make it easier for you, this is the equation that I've stated before. It's C with the 2 subscripts, carbon and hydrogen with the 2 subscripts, an oxygen molecule, and when they react together, they yield carbon dioxide and H2O. And I know this question may be a bit harder in relation to the one that I've just answered. However, in relation to if you want to answer the question, you may ask in the comments, and someone in the weekly takeouts will respond to you accordingly, step by step, on how you can answer that, if, of course, you do want to answer that. Thank you.
What is the empirical formula of a compound that is 28.7% K? I think it's potassium, I think, and 1.5% hydrogen and 22.8% phosphate, I think. And I'm sorry, I found over yes, and oxygen was hiding below me, and 47% oxygen. Let's put me over here again. So first of all, if you didn't know what an empirical formula is, I will explain it really fast. So yes, the empirical formula is the simplest form of a compound. For example, the empirical formula of C6H12O6 is CH2O because I have divided all of them by 6. all of them by 6, which will, but by the highest number that I can divide all of them. For example, another example is another example, C8 H18 will be, I'll divide both numbers by 4, which will be, I mean 2, which will be C4 H9, and that is the empirical formula very briefly. If you want to know it more than this, you can see the PowerPoint, or it's very easy. As we have covered it in trimester 1 and in this trimester. You can get back to the slides. It's explained very clearly. So we will start by taking the percent of each element and multiplying it and dividing it by the AMU of it, or the molar mass of this, which is the same. The AMU of the compound is the same, of the element is the same as the molar mass of the element. So first of all, we will divide 28.7 over 39, which is the 39 is the molar mass of potassium. So we'll make 28.7 over 39, which is 0.73. And the next question, we will make 1.5 over 1, which is 1.5. Then we will take the 22.8 over, yes, 22.8 over 31, which is 0.73 again. And then the last one, hiding behind me, oxygen, 47%. 47, we will make 47% over 47 over 16, so that will be 2.93. Then these numbers are not the empirical formula. The empirical formula will come right in this step. So we will look at this list, and we will see what is the smallest number in it, and then we will divide all numbers by this number. So here the smallest number is 0.73, so we will divide all of these numbers by 0.73. So the first one will be the potassium. Yes, the potassium, 0.73 over 0.73, which is 1. The hydrogen, 1.5 over 0.73 equals 2, and the rest is the same. So these numbers means that the potassium will have 1, hydrogen will have 2, phosphorus will have phosphorus sulfate, because I'm still confused, will have 1, and oxygen will have 4. So the compound the compound will be written like this, or not actually like this. This is just for clarification. K1H2P1O4, and the real compound will be written like this: KH2PO4. And that's it for this video. Thank you so much for watching. I hope you have understood anything from this video, and see you in the next video. Thank you for watching.